is a little bit more realistic type situation. So let's see how we would address this. This is number 90 from your textbook. A force of 65 pounds is used to pull a block up a ramp. If the ramp is inclined 18 degrees above the horizontal and the force is directed 38 degrees from the horizontal, then find the work done moving the block 12 feet along the ramp round to the nearest. Well, we have seen that work is equal to the dot product of the force vector times the displacement vector. But we're not given straight up what the vectors are in component form. We're giving magnitudes in terms of a distance and in terms of pounds, and we're given angles, but they're not in our typical form. Let's kind of look at what's going on. So here's the horizontal, pretend it's horizontal. And we've got a couple of different things. The ramp is inclined 18 degrees above the horizontal. So we've got this is 18 degrees. Then we have this block that the force acting on it is directed 38 degrees from the horizontal. So we've got a 38 degree situation as well. Now, think about what's associated with what. What's associated with 18 degrees, what's associated with 38 degrees. So the block is moving 12 feet along the ramp. So along the ramp is 12 feet. That's the magnitude. So there's the magnitude vector right there. Moving 12 feet at an 18 degree angle. There is our displacement vector. Well, what about the force? What's going on with that? Well, the force is acting on this block at an angle of 38 degrees from the horizontal with a magnitude of 65. Now, 65 pounds. And I know it can be kind of unsettling, like, wait a minute, what's going on with these different units? We've seen an example already where we had force in newtons, abbreviated capital N, and we had displacement in meters, which is abbreviated lowercase m. The dot product, or the work unit, was Newton meters. They need not match up in these work ones. Now, another unit for work is the foot pound. So it makes perfect sense in the physics world that you would have a problem that combines feet and pounds. So we don't need to do any conversions. You can't convert a foot to a pound or a pound to a foot. They're different types of measurements. But what we do need to do with these, though, is take these and convert them into their component forms. So let's start with our force vector. If you will remember, the horizontal component, which I will call A, is equal to the magnitude times the cosine of the angle. The vertical component is equal to the magnitude times the sine of the angle. So we use our calculators and we find out that A is equal to 51 to the nearest unit, and B is equal to 40 to the nearest unit. So we have our force vector is 51 vector I plus 40 vector J. Next we have our displacement vector. Our horizontal component for it will be magnitude times the cosine of its angle. Its vertical component will be the magnitude times the sine of its angle. So A in the displacement vector is equal to 11, I wrote 11.4, but it says the nearest unit, so we'll stick with that, plus the vertical component would be 4. So I got 11.4 and 3.7 if any of you are calculating too, which I hope you are. So A was equal to 11, B was equal to 4. So here's our displacement vector. 11 vector I plus 4 vector J. So the work that will be done will be equal to the dot product of force and displacement. So we'd have 51 times 11 plus 40 times 4 for a grand total of 721 foot-pounds.